Hello students, in this video lesson we will study about the next type of chemical bond, that is covalent bond. The chemical bond formed by the sharing of electrons between two atoms is known as a covalent bond. The sharing of electrons takes place in such a way that each atom in the resulting molecule gets the stable electron arrangement of an inert gas. The atoms share only their outermost electrons in the formation of covalent bonds. A covalent bond is formed when both the reacting atoms need electrons to achieve the inert gas electron arrangement. Now, we know that the non-metals have usually 5, 6 or 7 electrons in the outermost shell of their atom, except carbon, which has 4 electrons, and hydrogen, which has just 1 electron in the outermost shell. So, all the non-metal atoms need electrons to achieve the inert gas structure. They get these electrons by mutual sharing. A covalent bond can also be formed between two atoms of the same non-metal. So, we can say that whenever a non-metal combines with another non-metal, sharing of electrons will take place between their atom and a covalent bond will be formed. For example, hydrochloric acid HCl, chlorine molecule Cl2, etc. In the formation of a covalent bond between two nonmetals, each nonmetal shares one or more electron with the other nonmetal atom. Children, please note that the shared electrons are counted with both the atoms, due to which each atom in the resulting molecule gets an inert gas electron arrangement of either 8 electrons in the outermost shell or 2 electrons in the outermost K shell. Covalent bonds are of 3 types: single covalent bond, double covalent bond, and triple covalent bond. We will now discuss the formation of 3 types of covalent bonds in detail. Let us first discuss about the single covalent bond. A single bond is formed by the sharing of one pair of electrons between two atoms. Now, one pair of electron means 2 electrons. So, we can say that a single covalent bond is formed by the sharing of 2 electrons between two atoms, each atom contributing 1 electron for the sharing. Single covalent bond is denoted by putting a short line between two atoms. Let us take an example of formation of a chlorine molecule Cl2. The atomic number of chlorine is 17, so its electronic configuration is 2, 8, 7. Chlorine atom has 7 electrons in its outermost shell and needs 1 electron to complete its octet and become stable. It gets this electron by sharing with another chlorine atom. So, 2 chlorine atoms share 1 electron each to form a chlorine molecule. Since the 2 chlorine atoms share 1 pair of electrons, the bond between them is called a single covalent bond. The 2 shared electrons are counted with both the chlorine atoms for the purpose of determining its inert gas configuration. Each chlorine atom in the chlorine molecule has the electronic configuration 2, 8, 8, resembling its nearest inert gas argon. Therefore, a chlorine molecule is more stable than the 2 separate chlorine atoms. Let us take one more example of the formation of a water molecule H2O. Water is a covalent compound consisting of hydrogen and oxygen. The hydrogen atom has only 1 electron in its outermost K shell, so it needs 1 more electron to achieve the stable 2 electron arrangement of inert gas helium, and the oxygen atom has 6 electrons in the outermost shell, so it needs 2 more electrons to complete the stable 8 electron arrangement of inert gas neon. So, one atom of oxygen shares its 2 electrons with 2 hydrogen atoms to form a water molecule. Let us now discuss about double bond. A double bond is formed by the sharing of 2 pairs of electrons between 2 atoms. Since 2 pair of electron means 4 electrons, so we can say that a double covalent bond is formed by the sharing of 4 electrons between 2 atoms, each atom contributing 2 electrons for the sharing. It is represented by putting 2 short lines between the 2 atoms. For example, let us take the formation of oxygen molecule O2. The atomic number of oxygen is 8, so its electronic configuration is 2, 6. Therefore, an oxygen atom has 6 electrons in its outermost shell and it requires 2 more electrons to achieve the stable 8 electron inert gas configuration. The oxygen atom gets these electrons by sharing its 2 electrons with the 2 electron of another oxygen atom. So, 2 oxygen atoms share 2 electrons each and form a stable oxygen molecule. Since the oxygen atoms share 2 pair of electrons, the bond between them is called a double covalent bond. Let us take one more example of formation of carbon dioxide molecule CO2. Carbon dioxide is a covalent compound made up of carbon and oxygen elements. Carbon has 4 valence electrons, so it needs 4 more electrons to achieve the 8 electron inert gas configuration and become stable. Whereas oxygen has 6 valence electrons and it needs 2 more electrons to achieve the 8 electron configuration and become stable. So, one carbon atom shares its 4 electrons with 2 oxygen atoms and form a carbon dioxide molecule. There are 2 double bonds in a carbon dioxide molecule. The carbon atoms is in the middle of the molecule and the 2 oxygen atoms are held to it by the means of 2 double bonds, one on each side of the carbon atom. Let us now discuss about the triple covalent bond. A triple bond is formed by the sharing of 3 pair of electrons between 2 atoms. Since 3 pair of electrons are equal to 6 electrons, so we can also say that a triple bond is formed by the sharing of 6 electrons between 2 atoms, each atom contributing 3 electrons for the sharing. It is represented by putting 3 short lines between 2 atoms. Let us take an example of formation of a nitrogen molecule N2. The atomic number of nitrogen is 7, so its electronic configuration is 2, 5. This means that nitrogen atom has 5 electrons in its outermost shell. So, it needs 3 more electrons to achieve the 8 electron structure of an inert gas and become stable. The 2 nitrogen atoms combine together by sharing 3 electrons each to form a molecule of nitrogen gas. Since the nitrogen atoms share 3 pair of electrons among themselves, the bond between them is called a triple bond. Let us take one more example of formation of ethine. Ethine is a covalent compound made up of 2 carbon atoms and 2 hydrogen atoms, and its formula is C2H2. In the formation of ethine molecule, 2 carbon atoms share 3 electrons each to form a triple bond among themselves. The remaining 2 electrons of the 2 carbon atoms are shared with 2 hydrogen atoms to form 2 carbon-hydrogen single bonds. In ethine molecule, we have 1 carbon-carbon triple bond and 2 carbon-hydrogen single bonds. So, ethine is a covalent compound which contains single bond as well as a triple bond. So now we can say that the compounds containing covalent bonds are known as covalent compounds, which are formed by the sharing of electrons between atoms. The covalent compounds are made up of molecules, so they are also known as molecular compounds. Let us now discuss some important properties of covalent compounds. Covalent compounds are usually liquid or gases. Only some of them are solids. Covalent compounds have usually low melting and boiling point because covalent compounds are made up of electrically neutral molecules. So the force of attraction between the molecules of a covalent compound is very weak, and only a small amount of heat energy is required to break these weak molecular forces. Covalent compounds are usually insoluble in water, but they are soluble in organic solvents. Covalent compounds do not conduct electricity because they do not contain ions.